What's up? 12.2. We're doing permutations today. Permutations involve stuff called factorials. Factorials are when you put an exclamation point after a number. And what it means is you take that number and you multiply it by all the other numbers down below it. So 10 factorial does not mean 10, like you're really excited or something. It's 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. Just pay attention to those. They may or may not come up. I don't know. Alright, so here 4 factorial, this is 4 times 3 times 2 times 1. And that comes out to 24. 6 times 5 times 4 times 3, 2, 1. And what's that? 720. So you can imagine as our number here gets bigger, this number starts to get real big, real quick. Alright, this one, now since we just did that, you can think about, hey, that's 720 over 2 factorial is just 2 times 1 is 360. But most of us are not going to want to multiply all the numbers out. So what we're going to do is we're going to take the 6 factorial, we're going to write 6, 5, 4, 3, 2, 1 over 2 factorial is 2, 1. Any of our numbers that we can cancel out, we do. And then we multiply what is left. In this case, that also gives us 360. Alright. So let's multiply it all out here. 2 times 1 times 5 times 4 times 3 times 2 times 1. All over 4 times 3 times 2 times 1. Alright, so I got a 4 over a 4, or 3, a 2, and a 1. That leaves me with 2 times 1 times 5 is 10. Yeah. Nice. Alright. Yeah, we don't go adding these things. It's a crazy mess. Now what you might notice here from this last one, once I got to 4 here, all the numbers are all the same, right? So it's kind of like I could have had 2 times 5 times 4 factorial, right? And then cancel these out. It's 5 times 4 and all the numbers below it. And then that divides by 4 and all the numbers below it. And then that kind of works. So what we can kind of do here is we got 7 times 6 times, and instead of writing 5, 4, 3, 2, 1, I'm just going to write 5 factorial here. Why? Because 5 factorial is right here. Times 2 times 1. So now that whole factorial is just going to disappear on me. What's 6 divided by 2? 3. So I got 7 times 3 is all that's left here. Everything else is all crossed out. Equals 21. Alright, here, so we got 8 times 7, 6, 5, 4. Now as soon as I see my 3, I'm going to stop there because I see my 3 on the bottom. So my 3 factorial is going to cancel here and here. I got a 2 on the bottom, so I can cut one of my numbers in half. It doesn't matter which one. I'm going to cut the 8 in half. Leaves a 4. So we got 4 times 6, 7, 5, and 4 left. That's a big number. It's a 3360 left for you. So, like when you get to here, you do not want to write 100 times 99, 98, 97, 96, 95, 94, 100 times 99 times 98. Whoa, whoa, whoa. I don't know where that came from right there. I apologize. Over 98 factorial. That way my 98 factorials are going to cancel. 100 times 99 is just 99 with a couple zeros on it. And look at that. Yay. See, he's happy. He's not. That's too bad. Alright, so same thing here. We got 9 times 8 times 7 factorial over 7 factorial. 2 times 1. 7's will go away. 8 divided by 2 makes 4. So 4 times 9 leaves us with our 36 there is our answer. Now you don't have to divide that by 2 there. You can do 9 times 8 and get your big number, divide that by 2 and get your 36. It's up to you. I like canceling when I can. Now here, parentheses first. It's still parentheses first. So this is 9 minus 5 gives me 4 factorial, which we've already learned earlier that 4 factorial is going to equal our 24. So here we've got our 12 factorial over 12 minus 9 just leaves 3 factorial. Uh-oh. So I got 12 times 11 times 10 times 9 times 8 times 7 times 6, 5. 3 factorial over 3 factorial. Those cancel. You multiply all the rest of this mess. Let's see if I can copy this down right. 7, 9, 8, 3, 3, 6, 0, 0 is our answer there. And no, I'm not happy about that either. Ugh. Alright. So we got 7 over 3, which is 7, 6, 5, 4, 3 over 3. So our 3's go away. You multiply your 4 numbers you got left, and that's 840. Alright, so when we use this for permutations, this helps us find, kind of like combinations, kind of like what we were doing yesterday a little bit, but this time our order matters. It's not just, you know, choices by choices, but it is kind of the same thing. So we're filling in blanks for things. Order matters. So like runners in a race, it definitely matters whether you get first or last or somewhere in between, right? So if we got 11 guys running a race, 11 can finish first, but once that guy finishes, there's only 10 left for the next one. So it's just 11 factorial on down for how many different ways you can finish that race. That's a big number, a real big number. So our permutations and factorials are really similar to what we were doing yesterday with our counting principle. Alright, so here we got a first, second, and a third. This is how many choices we have for first, how many choices we have for second, how many choices we have for third. Now once somebody finishes that race, we lose that choice for second place, and that's why our numbers go down, and why it starts to mimic our factorial that we were doing before. So this, if you got 11 people in a race, there's 990 ways that they can finish first, second, and third. And that's why when you go to the track and bet on some horses, which, I don't know, most of us around here probably don't do that much because we don't have horse tracks, they give you really, really, really good odds on winning that, because chances are you're not. So they'll pay a lot of money to the one guy that wins because they're taking tons of money from all the people that are losing on something that they're probably not going to win on. Alright, so here we got 4 students we need to line up out of 15. So what we're doing here is we got 15 times 14 times 13 times 12. Multiply all of that ugly mess, and what do we get here? 32760. Ugh. Alright, Alice has some dolls. Too bad it's not Barbie again. She wants to place them on a shelf, so we're going to have 7 times 6 times 5. And that leaves us with our 210 different ways she can put those 7 dolls on a shelf for the first 3 spots. Alright, 12 skiers, first, second, and third. That's 12, 11, 10. B. We got 4 people. We don't even need to know their names. Put them in a row. Does order matter? Yeah. 4, 3, 2, 1. And that gets us our answer of 24 again. Oh, this time we're just looking at the first 3. Well, does that change anything? 4 times 3 times 2. Well, it's still the same. 24. Haha, crazy. Now they're going to go first vice president and president. That means there's 2 spots. We got our president and our vice president. So how many choices? 4 times 3 makes 12. And last one here. We got 25 kids on a team. We're going to go pitcher, catcher, shortstop. So there's 25 choices for pitcher. Can't pitch and catch at the same time, so there's 24 left there. And if you're doing that, you can't play short. So there's only 23. Multiply all of those, and that means our coach has a whole lot of different ways to set up his team. Alright, kids, be well, make some good choices. And look at that, under 10 minutes. What a good day.